This is the lesson slash the preparation video for the standard A.APR.4. It's from Unit 3. And what that standard actually wants you to do is to prove polynomial identities and use them to describe numerical relationships. And this evaluation really does do this. This unit is not an easy unit, and I think this is one of the harder ones. However, these are, it's very doable. So let me just go over some of the identities that are very common with this thing. With this topic. So first of all, you'll have squares. If you were to multiply a plus b squared, I'm just going to write in here really small. It's the same thing as doing a plus b multiplied by itself, right? So if we FOIL that out, if we distributed that out, we would get a squared plus 2ab plus b squared. Similarly, if we had the difference of squares, you would have a squared subtract 2ab plus b squared. So it follows that pattern no matter what you're squaring. And then with cubes, it also follows a very similar pattern. Basically, a plus b cubed being a plus b multiplied by itself 3 times. And if you FOILed that out with what we just did up here, with this part up here, then you would get this. You would get a cubed plus 3a squared b plus 3ab squared plus b cubed. Similarly, when we do the a subtract b squared, I meant to say cubed. So a subtract b cubed, you would have a cubed subtract a 3a squared b plus ab squared subtract b cubed. Now, these things are fantastic as far as like making your life a little bit faster. However, you may not ever use that, quite frankly. These are just identities. And what we're supposed to do with these, and they're things that are true always, and then how you would use them is maybe a, instead of a, it's like 3x. And then b, instead of b, maybe it's 5. So then you would substitute all of, then you would take, like, if that was 3x, then all the times that there was an a, you would replace it with 3x. And all the times that there was a b, if that was the 5, then you would replace those b's with 5, right? You'd replace all those with 5, and then you'd have what the actual thing was, and so you don't have to FOIL it out. A common other thing that you would have to do, these are other identities with polynomials, is the difference of squares. And if we had a squared subtract b squared, if you factored it, and so let me just give a hint that these are factors. If you factored it out, it would be a subtract b multiplied by a plus b. This is a very common one that you'll use a lot. Like, here's an example of this. If we knew that x squared subtract 9, if we had x squared subtract 9, that's the same thing as saying x subtract 3 multiplied by x plus 3. Because the square root of 9 is 3. Then we have the sum of cubes and the difference of cubes. So let me find the nicest. Okay, so then with the sum of cubes and the difference of cubes, they're very much related, and it's basically factoring it down to what it was. And so cubes, sum means adding, cubes means that both things are to the power of 3, and then this is what it would be. So if we had a cubed plus b cubed, it would factor into being a plus b multiplied by a squared subtract ab plus b squared. So notice that we have, this is a plus here, that's also a plus, and then this is the opposite. So like opposite goes right there. But if we had a cubed subtract b cubed, it is a subtract b goes right there, and then a cubed plus ab and plus b squared. I meant to put squared right there. Squared. And again, these are identities. Right now, you don't have to do anything. One of the questions literally on the quiz asks you to prove those things, to prove the sum of cubes or difference of cubes. So you'll have to remember how to distribute. So let me just do some examples of multiplying polynomials so that you can get used to what you'd have to do. Okay, so this is how you will use these. So first I wanted to show you how you could use it with multiple, when you're multiplying multiple polynomials. And these are questions very much like the ones on the actual test. So here's this one right here. If we had x subtract 3 multiplied, 3 subtract x multiplied by 3 subtract add x. Notice that that looks like the difference of cubes. It looks like this thing right here. So we know that it can be written like this. So let me take this where the a is the 3. So I'm going to write that down. I know that it would be like this is like the a and that's the b, and that's the a and that's the b. Let me zoom in again. Then I know that a multiplied by a, or a cubed, would be 9. Subtract, and then b would be x, and that would be x squared. So we can use those identities that we just did to simplify this part right here, becomes that 9 subtract x squared. Literally multiplied by 9 plus x squared. But then notice that this is the same thing. We have 9s and we have x squareds, and here's a subtract, there's an add. So we can do that same thing again. 9 multiplied by 9 is 81. And if we did x squared multiplied by x squared, that's x to the 4th. And that's it. That's all you have to do. So we use those identities to make this multiplying a lot faster. So notice how slick and easy that was. Then you're going to have to use that to prove things. So this b subtract 1 multiplied by b squared plus b plus 1, that's the same thing as the difference of cubes. So basically what we're asked to do in this problem is to prove this. Right, let's just double check. Yep, we're asked to prove that. So let's look at these different steps for how to do it. So the first thing with all of these proofs, the first one is going to be given. The next thing that we would use to prove it is just the definition of what that means. So the first thing we would do is we are going to split this up. So we're going to do b multiplied by the parentheses, and I'm going to switch colors for the sake of you being able to see it better. And actually, let me change it to this. And then the -1 multiplied by everything in the parentheses. So going to an easier color. So we would do b multiplied by b squared plus b plus 1. And then we would subtract 1. Oops, that's the pink one I wanted to do. Subtract 1 multiplied by b squared plus b plus 1. And that was the distributive property. And then we'd have to actually multiply that out. That's what distributing it is. So we'd have b cubed plus b squared plus b, subtract b, because we'd multiply that, right? Subtract b squared, subtract b, subtract 1, and that was just distributing. And then the next one is we could switch things around so that we would have the b squareds together. So we'd have b cubed plus b squared, subtract b squared, because we have both of those. And then we'd have the b's, put the b, just regular b's together. So plus b, subtract 1. That is the commutative property, meaning they commuted or moved. And then last thing we did was combine like terms. Slash, you cancel things. So like adding b squared and subtracting b squared, they cancel. Adding b, subtracting b, so we'd be left with b cubed, subtract 1. So that's what we did there. It also comes in handy when doing things like this. If we were given this thing squared, so this is going to follow the same pattern as this part up here, like these squares right here. It's going to follow this, and we have to prove that. But instead, our a and our b is really complicated looking. So this would be, this whole thing would be like our A. That whole thing would be like our B. And then they reworded it, or like basically this. So, and they go through this one. This one's a long one. It looks horrible. So first, so step one, they'd always have whatever they had there, like up at the top, the given. So it'd be 16x squared plus y squared squared, and the reason is given. But then we'd have that 16x squared plus y squared. What squared means is you're multiplying it by itself, so 16x squared plus y squared. And that is a definition of squaring something, of the exponent, I'll just put. And then the next step would be distribute. So we would have the 16x squared multiplied by the, like, so you're doing this multiplied by the whole thing on the right, and then y squared multiplied by the whole thing on the right. So 16 squared plus x squared plus y squared plus y squared, y squared multiplied by 16x squared plus y squared. That's distributing. Then you would actually do it. So step 4, and this is where, yeah, this is the important part. Nudge, nudge, wink, wink. So then you'd have big numbers. The big numbers. So what we're doing now is we're still distributing. But you're going to have big numbers. 16 multiplied by 16. Holy smokes, I don't remember what that is off the top of my head. So 16 multiplied by 16. Oh, is 256. So we'd have 256x to the fourth plus 16x squared y squared. That was the first part, right? That's when I did this. Yeah, now we're going to do y multiplied by these two things. So it's going to be plus 16x squared y squared plus y to the fourth. And that reason was we distributed. And then we will combine like terms. So we have only one x to the fourth, so that's 256x to the fourth. Those two were like terms, so we add those, so it's going to be 32 x squared y squared plus y to the fourth, which is totally true. And then I am going to do something kind of weird. And that is because what our goal is to get that thing at the end, because we want something squared added with something squared. And so they do kind of a weird substitution. So I'm going to do a substitute. So I'm going to change this color so we can see it's a different step. So 6. I'm going to substitute. So instead of 32, I'm going to change 32 x squared y squared. I'm going to call it instead. I'm going to call it 64x squared y squared subtract 32x squared y squared. So that's keeping the same value, but there is a purpose in doing this. So let's go to step 6 is 256 still, x to the fourth. But then instead of that 32x, we're going to have plus 64x squared y squared subtract 32x squared y squared plus y to the fourth. And then I'm going to move things around. So I'm going to use the commutative property. Commutative. So I'm going to put, with that, I'm going to put the extra stuff at the end. I'm going to put this thing at the end. So I'm going to have step 7. We're going to have 256x to the 4th. Subtract 32x squared y squared plus y squared, but then plus 64x squared y squared. All right. And now, if we were to look at this pattern, and it's complicated. So first, let me show you the pattern. I know that the square root of 256, because I just got it, was 16. And I know that 16 multiplied by 2 is 32, which is this thing. So this is the pattern that I'm using on this one. I'm going to come down all the way down here. Pardon me, still coming down to here, to this part right here. So this is the same thing. So on step 8, I'm going to say that that's the same thing as 16x squared subtract y squared plus 64x squared y squared. And that was using, we rewrite using the perfect square. So it's called the, they're squares. So this is called the perfect square trinomial. Oh, perfect square trinomial. Let's go back up to where our goal is. We've almost got that. Okay, and now step 9. Notice that, oh, did I do this right? Oh, I was supposed to have a plus right here, correct? Yes, that was supposed to be a plus. Whew, okay, good. So then this thing right here is the same thing as saying 8xy squared. So everything else stays the same. And that reason is the power of a product. Cool. Woo. So that was a huge one. That's the biggest one. And the next one really looks weird, but it's not that horrible. So let's finish this. So Pythagorean triples. Do you guys remember learning in geometry, or even like maybe you learned it in 5th or 6th grade, like a 3, 4, 5 triangle? It's a right triangle where one side is 3, this is 4, and this is 5. And it always works because of the Pythagorean theorem, which would say a squared plus b squared equals c squared. In other words, we'd have 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16, 5 squared is 25, and sure enough, 9 plus 16 does equal 25. So this is a Pythagorean triple. However, if you wanted to just come up with some random Pythagorean triple, no matter what the number was, if you wanted to like say big numbers, then you can use this lovely formula here. Maybe to you it looks horrible and not so lovely, but this is the formula nonetheless. So what we have here is they told us that we do have a Pythagorean triple, and that is 48, 55, and 73. So we can use this formula to create them. X has to be bigger than Y. They're saying if that's our Pythagorean triple, I put 2 P's. I always do that. If that's a Pythagorean triple, what are X and Y? Whew. Okay, and this is what it's saying. So let me just kind of break it down to basically this a squared plus b squared equals c squared. This is saying this is the a, that part's the a, this is the b, and that's the c. So in other words, we would have x squared subtract y squared equals 48. And then, because that's like the a, then also we would have 2xy equals the 55. So that comes from here. And that the c, it'd be x squared plus y squared equals 73. And we want to know what would x and y have to be? Whew. Okay. There are a couple ways of doing this one. This is how I'm going to handle it because there are a couple ways, and this is one that makes sense to me. So I'm going to add y squared to both sides. So I would have that x squared is equal to y squared plus 48. Now I'm going to put this whole thing in the place of this x squared right there. So then I'd have, instead of x squared, I'd have y squared plus 48 plus y squared equals 73. So then I'd have 2y squared plus 48 equals 73. And then let's see how I subtract 48. And I'd have 2y squared equals 5, right? 13 subtract 8 is 5, and 6 subtract 4 is 2, 25. So 2y squared equals 25. So y squared would equal 25 divided by 2, which is 12.5. And if we took the square root of that, we would have that y is equal to, I just picked random numbers. Maybe I shouldn't have picked these random numbers. I mean, by random Pythagorean triple. Okay, then this one would be the square root of 12.5, which is, let me see. I'm going to have to do this in the calculator really fast. So the square root, which if you ever have to type it in, you can use SQRT, square root of 12.5. And I think it's going to be, oh, it's horrible. So I'm just going to leave square root of 12.5. Okay, that's fine. But now I want to find out what x is. So now that I have that what y is, I can put it into something else. So let me put it into this one. We have 2xy is equal to 55. So I can do 2x multiplied by the square root of 12.5 equals 55. So divide by 2. Then x multiplied by the square root of 12.5 equals 55 divided by 2 would be 20. Oh, my brain is not working. 27.5. And then we would divide by the square root of 12.5. This is not a pretty one. Square root of 12.5. And then we get x is equal to just some crazy number that's not pretty. Not pretty. But I will tell you that this is the basic idea of what you'll have to do on the problem on the test. Okay, so hopefully that somewhat made sense to you. But those are the same steps. Like once you know what x squared plus y squared was, you can solve for x squared, plug it in, and then you should get something prettier than a square root. And then plug that back into the other one and find the other value. So we have x, we have our x, we have our y after plugging things in there. Sorry, but I'm just not pretty. Anyway, good luck.